Hello. How many program JavaScript? Do you all program JavaScript? Good. Node.js? io.js? Okay. It's been 20 years to the week, I think, since I first created JavaScript. I'll reminisce a little bit. There's a saying from Ian Hickson, the editor of HTML5, that things that are impossible just take longer. And that's true of many things on the web. People ask, what was it like to hack JavaScript in 10 days? People hear hack, code, right? You hack, program, hackers. It's a good word. Anyway, to create JavaScript in 10 days. This was me many years ago, I think 1993, doing a back handspring before I created JavaScript. And this is me after I created JavaScript in 10 days. It was victorious, but my hand got replaced by a chainsaw. It was difficult to create JavaScript quickly. There were problems. Java was supposed to be the real language. When I was recruited to Netscape, my friends said, come and do Scheme, the beautiful language Scheme, Guy Steele, Jerry Sussman, Lisp family language. Lisp with lexical scope. And simplified and cleaned up Lisp. When I got to Netscape, they said, oh, no Scheme, maybe Java? We're doing a deal with Sun Microsystems, and we're doing Java, so maybe you can do something like Java's little brother, Sidekick. Java is tall, JavaScript's short. So I had 10 days to do a demonstration, a demo, that it was worth having a little brother language for Java, to be called JavaScript. At that time, Mark Andreessen named it Mocha. So Java was big then. Java was why I had a chance to do JavaScript, but Java became this. Not good. It's gone now. But I want to give credit to Java, not just for the name that went into JavaScript's name, and not for the language, which is different from JavaScript. Think back to 1995. I don't know if anyone here was alive then. On television in the US, everyone had lots of hair, better hair, bigger hair. George Clooney, less gray hair. And I had my big break that year, of course. No. I used to go to Stanford University to read computer science papers. This is Margaret Jack's Hall on the Stanford University campus. They've moved the computer science department. It's no longer there. It's in a new building. But this is where I went because this is where the library that had all the papers on computer science was. And I remember a famous venture capitalist, John Doerr, said that even an idiot could have become a successful venture capitalist in the 1980s. All you had to do was hang around Margaret Jack's Hall. Of course, I wasn't a venture capitalist, but I went there anyway. So I was reading about Java because I'd been hired by Netscape and told that the language that I was to make, Mocha, to become JavaScript, had to look like Java. And I read this paper. This is from James Gosling. It was in a workshop in the ACM Special Interest Group on Programming Languages, SIGPlan. And it's a fun little paper from a long time ago. It's still not freely available, I'm afraid. Doesn't make sense. But it talks about how Java is a typed language that can be turned into bytecode, which can be turned into machine code fairly quickly. This was before the big just-in-time compilers like Hotspot existed. And I was building JavaScript to go into Netscape, the browser, and also into Netscape's server product of the time, a product called Livewire. I think they wanted to call Mocha LiveScript before they were sure that Sun would let them call it JavaScript. So someone wanted to use live as the name for everything. Livewire, LiveScript. And so I made JavaScript have bytecode, just like Java, only untyped. This is from James' paper. It talks about how Java code on the right, the syntax that looks like C++, it's, how many here know Java? Good. How this can turn into this. And the bytecode is instructions for an abstract stack machine, and it has type information encoded in the names, like A for pointers. I don't know why it's A, address, I guess, or object or array. I for integer. There are short instructions to get low indexed fields there and store them. There are branch instructions to jump on a condition, or unconditional jumps, go to. There's a return. And there is type information in the symbol table, the metadata also. So Java is a typed language and a typed bytecode. By blind luck and some amount of reading this paper, I made JavaScript bytecode. Okay. I made a lexical scanner and parser. The parser generated bytecode as it parsed. This required some care when the order of the source does not match the order of the bytecode, but it ran in one pass. Generated bytecode would then be interpreted by an interpreter. Because JavaScript has some reflection built right into the base language, you can turn functions back into strings. I made a bytecode decompiler also in those 10 days. That was a rush job. That decompiler caused me lots of pain later, fixing bugs. And I had very little in the way of a standard library. I didn't have time. Also, I was hoping to hook JavaScript up to Java, to connect Java and JavaScript so I could use Java's standard library. But Sun didn't make that easy. And so we had to add some things early on. I did almost all the work. Array was barely there. It was really objects with length properties. Date was the one built in that I had help. Somebody from Netscape offered to hand translate from Java util date in the very first Java release to JavaScript, to C code that would work in the JavaScript engine. So he took the Java code and rewrote it as C code, and it got built into JavaScript. That date object had serious problems. It had Y2K bugs, so-called. Two-digit years based on the year 1900. It was all based on Java, but to this day, people blame JavaScript. It's okay. I'm used to it. Let me show a little bit what people did, even though it was so primitive and so buggy and early. People did amazing things with JavaScript, even in 1995, and definitely in 96. This is a site, it's an art gallery. It's a little dark, but it's called Whitetail Butte Gallery. It's for an art gallery in Idaho in the United States. And it was built by somebody I knew online named Bill Dortch. He was using JavaScript and frames and frame sets. This is the old Netscape 2 innovation where you could have separate tiled windows, frames and frame sets. And he wrote it all in JavaScript. It was like an Ajax application, like a modern single-page application written in 1996. Before XML, HTTP requests, before JSON, before all that existed. If you look closely here, I'll try to make it bigger. No, it's not going to get bigger. If you mouse over these artists' names, they are JavaScript :URLs. They are links that go down to run some JavaScript. And they are, I'll show you the code, they are not HTTP links. They don't link off to a server. They run code locally. And so if I click on one of them, it should work. That's all local JavaScript. This was done in 1996. The code looks like this. Here's, you can see Bill Dortch's name up there. And this code was maintained into 1997 when the Web Archive archived it. So I don't have the original version. By 1997, things like script source equals existed. That was in Netscape 3. But no jQuery, no modern DOM, no JSON. You can see the navigator object here,
Right.
which was used to do some testing to see if it was Netscape 3 or Internet Explorer 3. Does anyone think that the new name for Internet Explorer, Edge, is a good name? How about the logo? It looks like a broken E. But Microsoft's doing well. They've gotten rid of all the old code. They got rid of VBScript, no more. So that's good. So one of the things I wanted to highlight in this code is it's not able to use asynchronous I/O, so it has to use links. It has to generate links from strings and then load them. And it has to do, instead of JSON, it has to use other ways of forming objects. I'll show an example in a second. But it's pretty clean code, written 19 years ago. Still works. So JavaScript is highly compatible. Here you can see a great deal of stringized HTML, mostly text, but some markup. Tables being generated. All of that then gets rendered through document.write or through setting location on one of these frames to a JavaScript :URL that evaluates to that string as source. Let's look at the data frame. This goes in a frame in the frame set that's an invisible frame. This is the data frame, and it contains constructor functions. Catalog, artist. They assign properties based on their arguments, their parameters, item, subitem, picture. And you can see it, because there was no JSON, Bill had to construct, using the new operator, instances using these constructor functions and nested them in a nice tabular way. If it were JSON, it would be a little cleaner, but it's the same idea. All this prefigured and anticipated what we do now with single-page applications. So I wanted to show that even in the early days when JavaScript was very little brother, not really toilet trained, it was still possible to do amazing things. And it was integrated with the browser in ways that Java never was. It could write HTML. It could handle link clicks directly without a plugin. This was extremely powerful, and I think helped JavaScript persevere and succeed where Java failed. Java is no longer really present on the client side of the web. Chrome recently turned off plugin support for old plugins that use the Netscape plugin API, the NP API. So no more Java unless they do something to reintegrate it using native client, which I don't think is going to happen. Now, obviously, there's been much progress since then. Asm.js, which I'll speak about more, was discovered. Asm.js, assembly subset of JavaScript, ASM for assembly, is a combination of a type system and some features of JavaScript that I put in from the very beginning, like the bitwise operators, the shift operators, that give you integers as well as floating point, 32-bit integers, and typed arrays from WebGL. Very important subset. ES6, the latest version of the JavaScript standard, ES6, also known as ES 2015, is all but done and being implemented. And typed arrays are actually in ES6 now. They started in WebGL. They're in all the browsers, including typed objects are coming in ES7. And people are thinking about types in a principled way for JavaScript. Even though it's an untyped language, they're doing TypeScript. Anyone here using TypeScript?
Not yet.
Very good. TypeScript is doing well. Anyone trying Flow from Facebook? Flowtype.org. There's also Dart, of course, and other languages I'll talk about. So here's my version of James' class vector from that paper. Instead of Java code, it's ES6 class declaration. ES6 allows a constructor. There's a typed array being created. There's a method shorthand. Instead of saying sum : function, you just say sum. And what I'll point out here is this is the same as James code from back here. But written in ES6 instead of Java. And it looks a little funny because I want to keep the integer variables typed as integers, which James Java code did by declaring them as of type int. Can't do that in ES6 yet, no type declarations. But I can cast them to integers using the bitwise OR operator and 0. So this little vertical bar 0 is a cast to 32-bit integer. So every time you see that, the values are being forced back into 32 bits, which allows the compiler to optimize them accordingly. So here's the Java bytecode from James' paper. Here is the ES6 code that corresponds to it. And it's true that bytecode might be smaller, but when you gzip this and gzip this, they're the same size. That's what you'd expect from a good compression algorithm and a good compiler intermediate form. It's surprising that it works out, but it does. And this is no less efficient, in fact more efficient in some ways than this to verify and to parse and compile to machine code and optimize. And partly that's due to the casts to integer, the OR zeros here, the bitwise OR 0, bitwise OR 0. Very carefully done. You don't want to do this by hand if you can use a compiler like Emscripten, but you can do it. This isn't pure Asm code, this is just an example. And JavaScript compilers in one pass can generate very good machine code with this. So by luck and some amount of studying computer science, I made JavaScript have inside its kernel language a bytecode, which needed typed arrays to be complete, but is now called Asm.js and is a very fast subset of JavaScript. It has deterministic performance, no garbage collection pauses, no just-in-time compiler misspeculation pauses or performance faults, performance cliffs. You see those even with V8 and other advanced engines, Chakra, SpiderMonkey. When they do just-in-time compilation, they have to guess or infer or measure what types will be at runtime. And if they're right, the code goes fast, but things change and then you have to recompile. And that makes the code take a pause while you recompile. That doesn't happen with Asm.js. And JavaScript is fine as a dynamic language. You should keep writing it by hand. Most of the time, performance is not a problem. On the modern just-in-time compiling virtual machines, very fast. But if you need it to go really fast as safe native code, as fast as Java or portable native client or Flash in its day, then use a compiler because compilers can preserve the types from their source languages. Compiling to JS is not a new topic. This has been around quite a while. Does anyone here know Google Web Toolkit? It's a way of writing Java that compiles to JavaScript to run in the browser. Or Open Laszlo before it, I think. CoffeeScript, obviously, and hundreds of compiled JS languages, including Dart. I'm going to show a demo done by Sean LeBron. This is very pretty. Written in ClojureScript, David Nolan's compiled to JS language based on Clojure. So this is one of those hundreds of languages. And this is Sean's idea of showing JavaScript as the sun. We're all just in orbit around it. And inside the sun are older versions of the language, because I mentioned even that site from 1996, that art gallery website, whitetailbutte.com, still runs. So ES3 was the standard formalized in 1999 that became the basis of modern JavaScript until recently. It had some extensions that all the browsers adopted after it. Those got codified as ES5. ES5 added a few more things. Here's Kangax's compatibility table. This is kangax.github.io. You can find it there. And for ES5, all the browsers implement it now. The green means every browser supports it well. There's a shim that's obsolete. That's the red. But all the browsers are doing ES5 now, which is good. And then ES6 is just being implemented and will take some time to be fully implemented because it's big. ES6 was the catch-up that took ideas from ES4 that were lost. ES4 was never done. It was abandoned on purpose in order to create harmony on the JavaScript Standards Committee, a condition of harmony that I named and helped to create a painful process that led to the modern world of peace, which is good. ES7 is coming, and we're trying to do it on an annual basis now, so ES7 will be called ES 2016 if we succeed. And if you look at Kangax's table for ES6, of course it's much more red. ES6 is a work in progress, definitely, and ES7 even more so. ES7 is not standardized, it's draft. ES6 is final draft, or approved for final standardization. ES8, I'm guessing there'll be an ES8. ES 2017. And Sean LeBron hoped it would have macros. There is a project that started at Mozilla Research. Tim Disney, grad student intern from Santa Cruz, did a great job. Sweet.js. Has anyone played with Sweet.js? You can use hygienic macros for JavaScript. They are implemented with a preprocessor, implemented using Esprima. It runs as a node program, so it's all a tool-time macros, ahead-of-time macros, not built into the browser. But there's a chance we'll get macros into JavaScript. That would be a good day, because then we wouldn't really need to extend the syntax anymore. You could do it by writing macros. Outside the photosphere of the sun, transpilers, linters, ESLint, JSHint, Doug Crockford's JSLint. Does anyone use ESLint here? No. JSLint? JSHint, it's a kinder JSLint. Module systems, NPM, require.js, the work in CommonJS that informed the ES6 module system. People got used to using tools to pre-process their JavaScript. Partly for Node, partly for Browserify. Does anyone use Browserify here? To take your Node programs and make them work on the browser, including the module requires calls. And that's good because that allows a new world of compiling to JavaScript. You can add static typing as a tool-time system, like TypeScript, Flow. The Clojure compiler from Google, not to be confused with Clojure, ClojureScript from David Nolan, Swanedet, and SoundScript, which is an experiment that's in progress in V8 to add something like ES4's optional types, but get it done and get it good enough this time. ES4 was too ambitious. The 4th edition tried to do gradual typing or optional typing. That was one of the reasons we abandoned it. It was too much. It was research. SoundScript will take that experience and other computer science research results and try to do something simpler that's still beneficial in V8, and if it works, we'll consider putting it into the language. So this is in view of the ECMA committee. This is an approved experiment. And then, of course, outside, we have languages, tool-time languages like CoffeeScript, obviously, and Dart now compiled to JavaScript language. That was, I said many times on Hacker News that was all it would be, so they should start working on JavaScript intentionally, and they finally are. We're seeing help from certain Dart people on improving JavaScript, which is good. ClojureScript, I mentioned, Swanodet's version of Clojure, and many more. There are hundreds of languages like this now. There are versions of Python and Ruby, OCaml, you see there. Haskell, PureScript is a very nice Haskell-like compiled to JavaScript language. And Emscripten, notably, which is the C++ to JavaScript compiler from Alon Zakai at Mozilla Research. This solar system is not to scale. There are hundreds of planets. It should look more like the galaxy, I suppose, or Firefly's solar system. Anyway, that's Sean LeBron's solar system of JS. And I'm going to talk about Emscripten in particular and show demos of it. Since Java started out as trying to compile efficiently, but died on the browser, and now JavaScript can compile to the metal. And Java on the server as a virtual machine is very successful in supporting dynamic languages through these extensions to the Java virtual machine and its APIs, its reflection facilities, to support Ruby, JRuby, Jython, the successor to the Rhino project, Nashorn, the JavaScript engine written in Java. I say that the circle is now complete. The little brother has grown up. The learner is now the master. I think this makes JavaScript Darth Vader, though, so that's not good. I don't want to be Darth Vader. I'll be Jackie Chan.
Okay.
That was me 20 years ago.
Okay.
And now there's been some mileage. But another thing we've done, which is good, in the old days when we standardized JavaScript and fought with Microsoft over it and cooperated with them, and they cooperated too, it was all in dark rooms. Now it's on GitHub. You can go to github.com, and there's an account, TC39. There's a repository called ECMA262. There are other repositories you can look at. I have a screenshot here from when Doug Crockford was still involved. Doug has stepped away from TC39 to do other things at PayPal, and I actually kind of miss Doug. Never thought I'd say that. But yeah, I like Doug. Selective tour of ES6. How many of you are using ES6? Using Babel, Tracer? Good. I'll go quickly. Some of the things are very simple, like string methods that we're missing. You could write a little bit longer JavaScript. You could say, instead of includes a substring, you could say index of greater than or equal to 0. It's painful. Now it's much nicer, and you can give a starting index, optional parameter. And there's, starts with, which doesn't look just for any substring, but a substring that starts at the beginning or at the optional starting position. Ends with an optional ending position. So sure enough, 6 is the fence post, and FUT are the last 3 letters before index 6. So that returns true. Simple things that were already in Perl 20 years ago. I didn't have time to put them in the standard library. And then as we standardized, it was hard to get people to agree, especially when we were fighting over ES4. So finally, I think everyone agrees we should take what jQuery or other libraries do. We should take the obvious things from other languages, like repeating a string, trimming space before and after non-space characters. And something else to do with strings, I didn't make a way to interpolate values into strings. You had to concatenate with plus. Like Java, made it look like Java. Also, I didn't have a way of having multi-line strings. ES6 adds that. This is the template string, so-called. The delimiter is accent grave, the back quote, or backtick, people call it. And you can have unescaped new line, that's a line break. You can have almost any characters without them being interpreted, other than backtick and $curly, dollar left curly. And that's how you interpolate the values of expressions. So these are finally in JavaScript. It's similar to what you have in Ruby hash. But there's even something better, which is based on template strings, and that's tagged template strings, where you can write a function and call it. No need for parens. You can just put the function name in front of the template. And again, the template string can have new lines and interpolated values. And the function will process the literal parts and the evaluated expression parts, the values. And it can sanitize them, it can remove leading indentation, as this dedent function does. You can have safe HTML tag template strings to prevent cross-site scripting attacks. You can have safe SQL to avoid SQL injection attacks. Something silly, we're adding binary and octal literals. There were many things I did in a hurry based on the C language. I actually put octal into JavaScript in a confusing way. Octal base 8 numbers, numeric literals, are useful still for permission bits for nodes, file system API. If you know Unix, you want to use octal still. Binary has its uses too. Here are some fixes. In such a hurry in the old days, I made global functions, is finite, is nan. They actually convert non-number arguments that are not numbers, to numbers. And if the argument is a string that cannot be converted to a number, you get this very strange not a number value. That's part of the IEEE standard. It's in Java, it's in every language of note, it's in our hardware, but it is confusing. You get imprecision, you get not a number is not equal to itself. And it's worse that these old functions, these global functions, convert their parameters. So there are new, cleaner versions scoped by the number object, namespace by the number constructor, I should say, that do not convert their parameters and can be used more reliably. There are new math functions. The math library was based on the Java Lang math package from 1995. It needed an upgrade. It needed hyperbolic transcendentals, some helpers for dealing with very small exponential and logarithmic function domains. Some bit operators that are very important for emscripten, like count leading zeros in 32 bits, and round to 32-bit floating point, fround, round to a single precision IEEE floating point number. Array, which we know and love, still a little bit sloppy, but it's also convenient that many things are like arrays but are not arrays. So in the DOM, node lists are not arrays. But if you want to use them as arrays, you can now using array.from. This example takes a node list and turns it into an array, a real array. And you'll see an arrow function here, which I'll talk about in more detail, to do the conversion. So it takes each element in the node list and replaces it in the resulting array with the inner HTML. And destructuring, one of my favorite features. This is something you'll know from other languages. Instead of just assigning variables like that, you can create a pattern that matches an object or an array in this case and bind the values from the individual elements. And you can reassign. You don't need to make fresh bindings. Works for objects too. So the property names M, D, and Y get extracted and bound to the variable names month and day. And there's a shorthand if you have the same name for the variable as the property, you just use the name once. Block scope, something I missed in the old days because I was in such a hurry. I only had function scope and global scope. var was the way you bound variables. Not only had a limitation of function or global scope, it also was hoisted. It was all or nothing. That was awkward. Now there's block scope. So if J is not in scope, this is an error, or maybe it's an outer J. Works for const, class, and function in block 2 in strict code. Here's the arrow function that I showed a little bit of. This is one of my favorite features. I had to fight to get this in. It's hard to get standards bodies to agree. It takes a while. If you use CoffeeScript, you know this. It's also like the fat arrow in C#. You can have a single expression as the body. If there's a single parameter, you do not need to parenthesize it, which is nice. If there are no parameters, unfortunately, the committee would not agree on making the empty list optional, so you need that. And multiple parameters there to add A and B. If you have a body that's bigger than an expression, you can do it. Here's an arrow that implements Ackermann's function, 2 parameters, multiple statements, early returns, which are convenient. Very recursive function, important in number theory, graph theory. That shows an arrow with a block body. And the best thing about arrows is that there's no pronoun trouble. In JavaScript, I made function be used for top-level procedures, constructors, methods, and callbacks or lambda expressions. 4 different things. And in all 4 cases, I only have one meaning for this, which is dynamic. And so this function on the outside is a method of car.prototype named start. It's meant to be called on a car instance. This will be the car instance. Unfortunately, it uses set timeout and wraps the this with an inner function which does not have its this bound properly. So this is a bug. You get the wrong this. In strict code, it's undefined. In sloppy code, it's the global object. With ES6 arrow functions, ES6 arrows, this on the inside of the arrow body means the same as this in the enclosing function, which is exactly what you want for callbacks. Great bug fix. ES6 has classes. I'm not sure I'm happy about this. People keep saying, you're turning JavaScript into Java. JavaScript is not turning into Java, but it does have more low-level APIs like typed arrays. It does have conveniences and affordances and things like arrows to reduce the opportunity for bugs, to eliminate hazards. And so when you write prototypal code like this, which is how you do code, like Bill Dorch's art catalog object and constructor, he had catalog and he set this properties. You can do that for animal. You can set a method, animal.prototype.breathe. Here's a template, literal. But it's much nicer in ES6. It's less code, it's less error prone, especially if you're doing subclassing, to use the new syntax. And the 2 mean roughly the same thing, so you can mix and match the common forms. Not every combination, but the common ones can be combined. So there's no Java here. It's all JavaScript. It's all prototypal. Here's a subclass, dog extends animal, and it adds a method, bark. You can subclass further. You'll notice the super is being used to delegate up the constructor chain to base class to assign this.name from name. And super can be used in a method, so the subclass here of bulldog breathes. All dogs breathe, so we delegate to our superclass because all dogs must breathe. And since bulldogs drool when they breathe, it's also going to drool. So that's all I'm going to say about classes. They are mostly syntactic sugar. They are sweeter, less error prone. You can still use functions if you want. Modules. I saw lots of people using modules, I think, earlier. Modules in ES6 try to embed the learning from NPM, from require.js, from Node in the language. Why in the language? Because you need syntax. In particular, you need import as a special form that the compiler can understand in order to prefetch the dependency, the binding for Baz from Baz.js. You need to know that this code in this file depends on this file. You cannot go and fetch it in the browser just as you evaluate the code, as you execute the code, because you'll have to pump the event loop and do I/O here, which will make race conditions around this point. So instead, it's prefetched, and it's prefetched based on the special form import. This shows how you import a particular binding that's exported, named Baz. So this is Baz.js. Here's app.js. It depends on Baz.js by importing just the Baz binding. It's a let binding. You can export many things. You can have default exports, something that Node people, many of them say is the only way to export one thing only. And that becomes the entire value of the export. So when you import it, no curly braces. But they also sometimes tuck extra properties on it, so we support that as well. You can have default and extra exports, and you can import them accordingly. There are lots more ES6 additions that I've spoken about in the past. I've spoken about default parameters. This allows you to have fewer arguments passed to a function, and the missing ones will be supplied from expressions evaluated on entry to the function. Very convenient. Gets rid of the arguments object, gets rid of extra prologue code in your function that you have to write by hand, rolls it into the default parameters. REST parameters, no more arguments object. You write ... and an R, or any name, at the last parameter position, and that's an array, a true array. The spread is the dual of REST. It spreads arrays out as positional parameters. For of loop, like for in, but iterates. Iterators, inspired by Python, cleaned up protocol, no exception throwing. Generators, easiest way to write an iterator is a generator function. Function star, and it contains yield. I'm not going to go into these for want of time, but my talk has links, and I'll push this to GitHub so you can follow the links. Map and set, weak map, weak set. Some metaprogramming facilities, proxy and reflect, and promises. So ES6 is big. This is the last of the big ones. We really can't keep doing these because it took years. We want ES7 to be small. We want it to come out in 1 year, be implemented during that year as it's being specified so that it's tested, and then on to ES8. I'll show a little bit of ES7. Async functions build on promises. How many people know promises? Who uses promises? Good. So here's an example of chained animations using promises for asynchronous programming. And it's accumulating a return value as the completion fulfillment value of each promise.then in a loop over all the animations in an array. And at the end, you have to use the catch method of the promise if you care about exceptions. Usually you don't. Or you have to finally fulfill that resulting promise with a .then that takes a callback, an arrow, and returns the accumulated return value. It's a little bit verbose, a little bit bulky. Here's what you can do with generators, which I mentioned. Function star, you can yield inside a function. No promises visible here. And you can put the try-catch in the language. Instead of calling it catch method, you can write a try-catch statement. It's better. ES7 proposes, even better, async and await. You may know something like this from C#, so that you don't have to write promises or generators, you just write async and await. And there may be even more conveniences coming in the way you write loops, we'll see. That's just one taste, and there's more coming. Single instruction, multiple data APIs. John McCutcheon of the Dart team started these, and with help from Mozilla and Intel, they're going into ES7, so you can do short vector instructions in your hardware from JavaScript safely. Typed objects, which are generalizing typed arrays. Value objects, including, very important, 64-bit integers, unsigned 64-bit integers. And we'd like not to just hard code value objects. We'd like you to write them. You can write decimal, big integer, whatever you want, rational. So we want user-defined operators and literals. I don't know if this will make ES7. It might be ES8, 2017. Async generators, the list goes on. Let me do some demos. Asm.js, I mentioned, is this assembly JavaScript that can be turned into machine code with definite performance, memory safety, control flow, integrity, fast as Java, fast as native client, fast as Flash. This is a big deal. It's supported by Microsoft now in a big way in Eich. It's supported in the new version of V8's JIT turbofan. So I'll show some demos. Let me start with, this is a Unity 5 game. It's a little bit gory. I apologize. It's a zombie game. I don't know if I have sound. Sound helps a lot. The best thing about this game are the sentry chickens. Sound. The sentry chickens will take care of those zombies for you. You don't have to worry about them. Uh-oh, here comes a big tanker guy. I better hide from him if I want the sentry chickens to get. Oh, there. I love my sentry chickens. I'm very fond of them. Unfortunately, their machine guns overheat and they explode. Very sad. This tanker is going to get me. This kamikaze is going to throw a grenade. Oh, zombies are chewing on it. You might wonder why they're carrying so much cash. Why are zombies carrying money? Anyway, 60 frames a second, WebGL, JavaScript running as a bytecode, as fast as any of the safe virtual machine-based bytecodes out there. This wasn't thought possible even a few years ago. This has taken quite a bit of work from Mozilla leading the way, and then Microsoft and Google and I think Apple on board. One more game. This is to close out. This is Unreal Engine 3, the Sanctuary level. I'm going to show you the Asm.js first, though, if I can. This is what it looks. The code looks like that Emscripten generates. This is the pretty handwritten code in the prologue. But if you look for use Asm, that's the directive. Where is it? I'm not finding it. I may have wireless troubles here. Anyway, I'll try to show you the code because it looks like bytecode. Here's the game. Notice some APIs like full screen are important, and web audio as well as WebGL. Oh, robots. Fortunately, I'm indestructible. I can't. This game as it shows WebGL off. Thank you. If you follow this game, you can play, collect weapons, sneak up on your friends. There's a teleport on the if I run at this and jump, I can go on the roof. Whoa, there's Fred. Won't he be surprised? Okay. Anyway, that was a C++ code base, multi-million line code base, compiled by Emscripten. It took 4 days to get it working. Had to fix Emscripten bugs, had to make a shim from open audio to web audio, and then it worked. And Tim Sweeney of Epic Games was stunned. He thought it would take years to do this. It took 4 days. That was in, I think, fall of 2012, if you can believe it. They're on to Unreal Engine 4. I showed Unity 5. And so this is why Now that the circle is complete and JavaScript is the web bytecode, I say always bet on JavaScript. Thank you very much.